you attend to this next video, in which I'm going to run through the second way that we can solve simultaneous equations, and that's via a process called elimination. What we're effectively going to do is we're going to be able to eliminate a pronumeral. So we're going to eliminate either the x pronumeral or the y pronumeral, and we're going to do a special little trick called elimination. We're going to show you how it works, how it's done. First of all, the reason we would use elimination is when you have equations similar to the ones that I've got on the screen right now. So you'll see them in more of a general form. So you've got the x and y pronumerals both, say, on the left-hand side of the equation, and then a number on the right-hand side. That's typical of the ones that you would complete an elimination process for. Of course, if you had them in the form y equals, like in the previous video that I recorded, those ones would be more suitable for a substitution method. So elimination is not always the best method to go with. So what we want to do is we want to try and eliminate a pronumeral, and I'll show you how we do that. First of all, it is going to be a little bit strange, this particular process. It's not something really that we've done before, so bear with me with this. What I'm going to do throughout all of these examples, you'll notice, is I'm going to label my equations. The reason is that sometimes I'm going to be creating more than one equation. I might be creating what's called an equivalent equation. So with these ones, what I'm going to do is I'm going to label them, and to do that I'm just going to put a number and I'll put that in a circle to show that it's the label of that equation. So this first one's equation 1 and equation 2. So what I'm going to do here to eliminate is, first of all, I notice I've got a positive y pronumeral here, and here it's minus y. So they're obviously the opposites. And what I would like to do is add them together. So it sounds a little bit strange, but what I'm actually going to do is I'm going to add one of my equations to the other one. Now that does sound very strange because we don't do this regularly. It's not something that we do on a regular basis, but it can be done, and it's really, really handy when you want to eliminate a pronumeral. Now, of course, I've added them together. You can also subtract equations from each other as well. So what I'm going to do is I'll show you how we would write this. So if I take equation 1 and I add that to equation 2, what you want to do is you want to look for like terms, obviously. So I'll start with the left-hand side of the equation. I'm going to add my 3x to my x. So on the left-hand side, I'm going to have 3x plus x. My next term is y, so this is going to be plus y. Now remember, I'm adding that to the second equation, so it's going to be plus minus y, which is just minus y. And then what I'm going to do is work on the right-hand side. So you work with one side at a time. I'll have my 13 plus 3. I'm just going to do write that straight up as 16. Alright, so what you'll see is, the reason I did this, of course, is to try and eliminate, hence the name, the y pronumeral. And I've done that because by adding the positive y to the negative y, it does cancel it out. It becomes 0 effectively. So my next line of workings will be basically a tidy up and a solve. So I will collect like terms. So I've got 4x equals 16. So therefore x is obviously equal to 4 because x is 16 over 4. So there I have my x value that satisfies, that is part of the solution to my simultaneous equations. What I haven't yet got is my y value, and my y value I can get by using either equation. I might use the x minus y equals 3 because that one looks easier to work with. If x minus y equals 3, and I've got my x value is equal to 4, so 4 minus y equals 3, then obviously y must be equal to 1. Therefore, my solution will be 4, 1. Now what we can do, of course, is we can check. We can check whether that satisfies both of these equations. So what you want to ask yourself, I'll just substitute both into the rule. 3x plus y equals 13. So 3 by 4 plus 1. So 3x plus the y equals 13. 12 and 1 is 13, so yes, that works. The other one, of course, is x minus y. And that also works. So that's our little checking measure that we use at the end to make sure that our solution that we have here does satisfy both equations. So there's one example of an elimination method. So one thing that you want to remember is, well, a few things you want to remember. You want to label your equations because then it makes it really clear what you're doing. And see how I said, okay, I'm taking equation 1, adding equation 2. You should always be doing that in your working, so it's very clear to me what you've attempted to do. I will show you some other ones. This is where so this one we added the equations together. I want to show you where it would be necessary to perhaps subtract one from another. Here's an example here. You'll notice we don't have the same thing as before. We don't have one pronumeral that was positive and then one with the same coefficient that was negative, which is why I could add the others together. This one here, what I do have are two pronumerals that are identical. So I've got a 2x and a 2x in both of my equations. And when you have that, straight away you should consider subtracting one from the other. And I'll show you why I would do that. So again, label them. Next step, I'm going to say equation 1 and I'm going to subtract equation 2 from that first one. So effectively, this is what's going to happen. I'm going to have 2x minus 2x. Okay, try and keep your like terms together. It just makes it a whole lot easier. I'm going to have 3y minus, I'm going to use a bracket here because I'm subtracting. Remember, I'm subtracting this entire equation, and this is already a negative y. And that's going to be 14 minus 6 on the right-hand side. So I subtracted the x terms, I subtracted the y term, I subtracted the 6 from the 14 as well. Now let's clean it up. Now again, this is why I subtracted, because now this term is eliminated. Once you eliminate a term, you're left with just one pronumeral, and then you can solve it. So here we've got 3y minus negative, so plus y. 3y plus y is 4y equals 14 minus 6, 8. So then, of course, y equals 8 on 4, which is 2. So I've got my y value of the coordinate that I'm looking for. I will then find x. Now, to find x, you can use either of these two equations. I'm just going to use the 2x minus y, because again, just like the look of those numbers. And I'll substitute my y value into there. So my y value that I got was 2, so I'm going to have 2x minus 2 equals 6. Add 2 to both sides, 2x is equal to 8. So x is 8 on 2, which is 4. Okay, so my coordinate, therefore, my x value was 4, my y value was 2. So my answer is 4, 2. Now, again, we can do a little bit of a check. If I just go back to the top, I might just use a different color just to show you I'm just checking my answer at this point. So my x value I got was 4, so we should get 2 by 4, just substituting back into the original form, original equation. My y value I got was 2. That should be equal to 14. So this would be 8 plus 6, okay, so that works. Then I've got 2 by 4, so 8 minus the 2. Okay, both of those work. So I know that my solution to the simultaneous equations is correct because it satisfies both of the equations. So this equal sign is true. The left-hand side equals the right-hand side in those equations. So there you have a couple. So the first one I had to add them together. The second one I chose to subtract one from the other to allow me to eliminate. So always looking for whatever process will allow you to do that elimination. The next one that I would like to do, I am going to do a little trick to allow me to do this process, because sometimes it's not always nice and easy like these two. Sometimes you have to manipulate your equations a little bit. So that's this one here. As you can see, the coefficients on the x's are different. So if I was to try and add them together or subtract one from the other, it's not going to eliminate. And it's the same thing it's the same deal with the y's. If you have a look, I've got negative 3y and I've got positive y. So adding them together or subtracting one from the other is simply not going to work. So there are a couple of things that you can do here. There's a couple of options. First of all, I can choose to, say, eliminate the x's, or I can eliminate the y's. I am going to show you both ways with this particular example, but that wouldn't be necessary if you were doing this question. You'd only need to do one of these ways to get to arrive at an answer. So hopefully I'll have enough space. I might have to keep this to the left-hand side, maybe split it down the middle so I allow myself enough space here. So first of all, what I'm going to do is, if you have a look here, my y's, as an example, are different. But what I can do is a little trick. First I will label these, 1 and 2. See how I've got negative 3y and I've got positive y. What I really want is I want this term here to say plus 3y, because then I could just add them together and the y's will be cancelled. So what I can do is I can make that a plus 3y by multiplying that term by 3. Now, of course, if I multiply a term by 3 in an equation, I have to do that to the entire equation to keep it equivalent, so to keep it the same, or to not change the actual line that is represented by this equation. So what I'm going to do is I'm going to take that equation 2 and I'm going to multiply it by 3. So that means multiplying the entire thing by 3. So that's every single term must be multiplied by 3. What I generate is called an equivalent equation, and it is actually the same line. 63. This line here, 12x plus 3y equals 63, is the same as 4x plus y equals 21. So if you were to find the x and y intercepts of both of those, you are going to see that they are exactly the same line. By doing this, I've created a third equation. I'm going to call this equation 3. Just put a circle around it. So I've got equation 1, 2, and 3 now. Now what I'm going to do is I'm going to work with equation 1 and 3. I'm going to add them together. The reason I want to do that is you'll see I've got minus 3y, and in this one I've got positive 3y. So when I add them together, they're going to eliminate. So equation 1, I've got x. In equation 3, I've got 12x. So they're going to add together. Then, of course, I've got plus 3y, take 3y. And I've got in equation 1, I've got 2 on the right-hand side, and I've got 63. So that's going to be equal to 65. This is going to cancel out. So plus 3y minus 3y, that's now gone. It's eliminated. I'm left with 13x equals 65. So x is 65 on 13, which is 5. So there I have my x coordinate. I of course need the y one. So I might just use one of these rules. So one of them was x minus 3y equals 2. So that's just going back to my original equation 1. Substitute in my x value. So it's going to be 5 minus 3y equals 2. Now I'll do a little bit of rearranging. I'll subtract 2 from both sides. I'll add 3y to both sides. Just did that in one step. So 3 equals 3y, so y must be equal to 1. So my solution is 5, 1. Now you can, of course, do your little check. So 5, 1. So you should have 5 minus 3 by 1. So 5 by 3 is 2. 4 by 5 is 20. 20 plus 1 is 21. So that works. I know that my solution is correct. Now I just wanted to mention that there was another way that I could have done this, a very similar way. I could have actually taken equation 1 and multiplied that by 4, because of course then I would have 4x here and 4x there, and then I could subtract 1 from the other. So I'll quickly show you that method. So taking number 1, multiplying it by 4, this would give me 4x minus 12y, because remember you have to multiply everything by 4, that will be equal to 8. Now I'm not going to call that equation 3 because I've already got one over there. I'll call that equation 4. Doesn't matter what you call them, so long as they're easily identifiable. If I now take equation 2, which was that one there, and I subtract this new equation that I got, which is equation 4, I'm going to get 4x minus 4x. Now, of course, that just cancels out. So I tend not to do this step. I tend not to bother writing that bit. I would just go with the 1 minus the negative 12. So that would leave me with the 13. I'll put that out. I'll write that in full, sorry. Positive y minus the negative 12y. Now that will be equal to 21 minus the 8. So I've got 1 minus the negative 12, so 1 plus 12. 13y equals 13, so y is equal to 1. Now you'll notice that's exactly what I got on the left-hand side. When I did a different way, that's what I should get, because it will be the same answer, no matter what method that you use. So I've got my y equals 1, and then of course I'll substitute just like I did when I did it the other way. So x minus 3 times 1 is 2, so obviously x is equal to 5. So 2 different methods in terms of what I did do with the equations. So I created equivalent equations in both cases, but I did it a different way. So one was focusing on eliminating the y. So just going up a little bit here. This one on the left, I eliminated the y. If you did it a different way, you might instead eliminate the x. Either way is fine, because you will arrive at the same answer, provided all of your algebra work is correct. This one here, I had to add them together to eliminate the y. That one there, I had to subtract to eliminate the x. So you're going to have to be very flexible with these. There's not one way that you can do it. There's not one solid way that you must do it as well. So you will need to be very flexible. I will show you one more along these lines that is a little bit more challenging, because there are a couple of steps involved, and mention why that is the case. And I'll show you one last one as well, which is along the same lines as what I mentioned in a previous video, and that was to do with lines that are coincidental or coincide. So I'll just go to the second last example, and that's this one here. You'll notice I've got an issue with this one. I can't really do it the same way that I've been doing the other ones. The other ones, I had one really simple way, factor that I could multiply by one of the equations to generate an identical term, or a term, say, just with an opposite sign. With this one here, I'm dealing with a 3 and a 5 for my x's, and I've got a 5 and a 3 for my y's. So what I wanted to show you is, this is actually an example where I need to create 2 equivalent equations. Call this 1 and I'll call it 2, just like I have done all the way along. Now to eliminate, I need one of these terms. They're both positive. They're all positive at the moment, so I'm not going to worry about, say, subtracting one from another. It's not going to be possible. well, no, I'm not going to worry about adding them together, sorry, because that's not going to be possible. What I'm going to have to do is subtract one from the other. And to be able to eliminate, I need a coefficient to be the same. So I need this 3 to be the same as, I need the coefficient of the x to be the same as the coefficient of the x in that term. So this is a little bit like finding a common denominator in a way. That's probably what I liken it to. You want the lowest common multiple of the 3 and the 5, which is obviously 15. So what I'm going to do is I'm going to take equation 1 and I'm going to multiply that by 5. Because what that's going to do is that's going to give me 15x plus the 25y equals 5. And I'm going to call that equation 3. Now equation 2, since I need this coefficient to be the same to be able to eliminate, I also need it to be 15. So equation 2 is going to multiply by 3. That will generate 15x plus 9y equals 7 by 3 is 21. I'm going to call that equation 4. Now what I've done is I've created equivalent equations to what I had with to begin with. So now I've got a 15x and a 15x. So of course now I can do 3 minus 4. Equation 3 minus equation 4. Now, of course, that's going to be 15x minus 15x, so that cancels out. Again, not absolutely necessary to do that step, but I'm doing it just to show you what has happened here. I'll then have my 25y minus 9, so I'm left with just, well, I'll write it out in full. I'm just going to be left with 16y. Negative 16. Well, you can actually write 5 minus 21 in this first step, just so it's more clear in my workings in your workings what you've done. Okay, so equation 3 minus equation 4. Now we will collect the like terms here. So I've got 16y equals negative 16. So y would be equal to negative 16 on 16, which is negative 1. Alright, so now what I want to do is I want to use one of my equations from earlier. I'm just going to use equation 1, which looks like this. And I'm going to substitute what I got here for my y value. I'm going to substitute that into this rule so that I can solve for x. So this is 3x minus 5 now. Equals 1, so add 5 to both sides. 3x equals 6. X equals, oops, I've run out of room here, 6 on 3. So x is equal to 2. Alright, so my answer, therefore, just do it nice and large over here, it would be 2, negative 1. Now, of course, we can check, we can go all the way back to the top with our original ones here. X value of 2, y value of negative 1, we want to check that that equals to 1. So that's 6 minus 5 is 1, so that's good. Second one, 5 by 2, so that's 10, plus 3 by negative 1, so that's subtract 3, 10 subtract 3 is 7. So that's good. We do have the right answer because it does satisfy both equations. Now, back when I first introduced you to this particular, skill of simultaneous equations, I mentioned that two lines will not have a unique solution, or they will not have one answer if they are the same line. So if they actually sit on top of each other, so they are exactly the same line. So I just wanted to mention that with this particular example, because if I was to go ahead and attempt to solve these. So say I called that equation 1, that equation 2. I take number 1, times it by 2, so that I can get the 4x here. What you're going to find is you actually get the same line. So when I multiply this out, I get 4x plus 8y equals 6. Now that is equation 2. So what has happened here, this is obviously equivalent. I'm having trouble writing with this thing. These are actually what we call equivalent equations. So what you'll see is if you can multiply one of them by a factor to generate the next one, you actually are working with lines that coincide and they are exactly the same. So if I go ahead and I find, say, the x and y intercept of each of these, what I should find is they are identical. Now, I'm not going to do that right now, but what you could do is you could pause this and check it out. So what I mean by that is if these are the same lines, they have exactly the same intercepts. So you could work out the the y-intercept by substituting in x is 0 to both equations. And what you should find, both of them, you get a y value of 3 over 4. You could then check your x-intercept as well. This is obviously just me proving a point. Y equals 0. You could substitute them in, and what you'll find is you'll get x-intercept for both of them of 3 over 2. So you can go ahead and check that if you don't believe me, of course. But if you ever come across two like this and you multiply one by a factor and you generate the second equation, then you actually aren't going to get one point of intersection. You have an infinite number of points of intersection if you're talking about two lines that are identical. Now, the other issue, of course, the other time where you won't get an answer is if the two lines are parallel. So if you come across an example where there's a problem, do check the gradient of each of these. So you would rearrange these into the form y equals nx plus b. And if you do have an m value, a gradient value that's the same, then you're not going to get an intersection. So you're not going to get a point of intersection. You're not going to get a solution to those simultaneous equations. So just beware of that. I wanted to mention that because that's a case that does exist. So two possible cases that do exist. I'll end it there because I've gone on for a little bit now. Hopefully that's given you a little bit of an introduction, a bit of a foundation to work with your elimination.